Hello and welcome to this example video where we'll work through an application of the cross product. We'll work out a torque example. So let me just refresh your memory about how to calculate torque with a cross product. So you can again imagine a nut, a bolt, and a wrench, that three-body system. So we have forces applied to the point P at the head of a vector r. So this r vector is our sort of our wrench vector, but whose length is given to where we're applying the force. The twisting effect will be r cross F. And the magnitude of the torque is, as we know, the magnitude of the cross product, which is magnitude r times magnitude F times the sine of the angle between them. And then the direction of the torque is given by the right-hand rule. Remember, point the fingers of your right hand in the direction of R, curl them in the direction of F, whichever way your thumb is pointing, that's the direction of the torque. So let's look through an example here. Here we have our familiar system, and we're given some figures here. A force of 20 newtons is applied to a wrench, perpendicular to the bolt. So the question is, which produces more torque? Applying the force at an angle of 60 degrees on a wrench, so that would be this system here. We're applying our force at 60 degrees to the wrench, so that's this quantity here, 60 degrees, with a force of 20 newtons. Oh, right, so the difference here is 60 degrees on a wrench that's 0.15 meters long, so that's this magnitude of R would be 0.15 meters long. Or applying the same force, 20 newtons, but this time at an angle of 135 degrees, so like this, on a wrench that's 0.25 meters long. So that's what we're trying to work out here. So one important thing in sort of math in general is to be able, we have so many different ways to calculate cross product, right? We know the magnitude, as I had on the previous slide, the magnitude of the cross product is the magnitude or it's the product of the magnitudes of the two, of the R and the F times the sine of the angle between them. We also know that the cross product can be calculated by doing a bunch of algebra. We also know it can be the determinant of a 3x3 matrix. So the question is, which of these do we use for a given problem? And the idea is to look at what information you have to figure out what's going to be the easiest calculation. So in this case, we're given information about the magnitude of the force, the magnitude of the lever arm, and the angle between the two. And so what we want to use then is the what I mentioned up here. Magnitude of the torque is magnitude of R cross F, which is magnitude of R times magnitude F times sine of theta. So I'm going to use that for both of these. If I were given vectors for F and for R, I would be using the determinant of a matrix to calculate the cross product. So in this first case, we have that the magnitude of the torque vector will be the magnitude of the force vector times the magnitude of the lever arm times sine of the angle between them. And let's collect our information. Magnitude of F is 20. Magnitude of R is 0.15. And then theta is 60 degrees. So this will be times sine of 60 degrees. Now, sine of 60 is square root of 3 over 2. 20 times 0.15. So what? 2 times 0.15 would be 0.3. So that'll be 3 times square root of 3 over 2. So this is going to be 3 square root of 3 over 2. And that's the magnitude of my torque. We also want to work out the direction of this. Well, actually, we don't really need to. We're just asking about how much torque is happening. But you could work out the direction of this. So point your fingers along the lever arm, curl them in the direction of F. It'll point up along the bolt. And so this will have a tightening effect. So that's this first case. So I'll say case 1 here. And then let's see, in the second case, again, magnitude of our torque is magnitude F times magnitude of our lever arm times sine of the angle between them. Let's see, magnitude F is 20 again, but now our lever arm is different. It's 0.25 meters, so that's the magnitude of our lever arm. And then sine of, what, 135. So 135 degrees, that's 45 degrees passed straight up. And so our sine of that is going to be square root of 2 over 2. Or rather square root of 1/2 or square root of 2 over 2. Either way. So that's 20 times 0.25, 2 times 0.5, so this is 5 times square root of 2 over 2. 5 square root of 2 over 2. So what's bigger, 3 square root of 3 over 2 or 5 square root of 2 over 2? Maybe we still can't tell. I can't tell right off the top of my head, so I'm going to approximate each of these. So 3 square root of 3 over 2, that is about 2.598. And then over here, 5 square root of 2 over 2 is about 3.536. And so we have our answer. In case 2, more torque is generated. So if we're given the choice between these two and we want to generate the most torque, by the way, these are also both going in the same direction. We're both tightening it. So if I have the choice between these two, I would rather do it here, the longer lever arm at this angle, than the other one. Gives me more torque. All right, that's it for this one. In the next one, we're going to examine a different case of the cross product, different use of the cross product. It's another kind of twisting motion, but in this case, it's the magnetic force that a moving charge feels as it moves through a magnetic field. All right, I'll see you there.